Hello students, how are you? My name is Fikru Marga. Today I'm going to teach grade 10 physics, introduction to basic electronics. Students, we learn unit 4 about magnetic force. Under this magnetic force, we see about the factors that affecting the size of magnetic force. Can you tell me the factors that affecting the magnetic force? Student, the factors that affecting the magnitude of the magnetic force is the length of the wire, the current passing through the wire, and the magnetic field, if you say this is correct. And also we see about transformer. Under this transformer, we see about step-up transformer and step-down transformer. Do you know the difference between step-up transformer as well as step-down transformer? Student, discuss with each other, because step-up transformer is the type of transformer if the number of turns of the secondary coil is greater than the number of turns of the primary coil. This is what we call step-up transformer. But step-down transformer is if the number of turns of the primary coil is greater than the number of turns of the secondary coil, we say this is the step-down transformer. Now, today we are going to start about introduction to electronics. This is our third lesson that we come together. So, under this we are going to look about 5.1 vacuum tube device. Under this, by the end of this session, you should be able to define the term electronics and state the importance of electronics in your daily life. State what it means by thermonic emissions. Describe the behavior of vacuum tubes. Describe the function of these cathode ray tubes. And represent both DC and AC on a current time or voltage time graph. We will see about how to draw current time, a DC versus voltage or current time graph. And use the current time or voltage time graph to find the period frequency of alternating current or voltage. This is the main point that we are going to see under this unit. Student, let us define about thermonic emissions. What is thermonic emissions? Student, thermonic emission is the emission of electron from the heated metal surface, or the escape of electron from heated metal surface. If metal is heated, electron started to emit from this metal surface. So without heating, nothing electron is emitted from the metal surface. So to emit electron from this metal surface, we should have to heat to high temperatures. So while that electron is started to emit. So cathode rays oscilloscope is a piece of equipment that is important in using in studying and displaying electrical signal or oscillations. So under this thermonic diode contain a cathode, anode, and the heater. If you look from the diagram, this is thermonic diode diagram. This thermonic diode diagram contains this is a cathode and this is an anode. This is generally it is a vacuum. Cathode is at negative potential, while that anode is at positive potential. There is a reason that why we connect anode is at positive potential and cathode is at negative potential. The reason is, since electrons start to emit from the cathode surface by heating, then it is pulled toward the anode. That is why we connect anode at positive potential and the cathode at negative potential. So the source of our voltage is AC, alternating current voltage, and there is electron flow such type from right to left to the cathode. Student, this is diode, a device that has two electrodes. Diode is a device that has two electrodes. The two electrodes of diode is, one is cathode and the other is anode. So student, you know about the function of the cathode to emit electron after heated. So the function of the diode to accept the emitted electron from the cathode and guide to the fluorescent screen. So this is the thermonic diode diagram. From the diagram of thermodiode, electron boiled off from the heated cathode were attracted to the anode. When electron is emitted from the cathode surface and attracted toward the anode, because anode is at positive potential. So the main use of device or diode is for rectification. That means to get a DC from AC. This is the main use of diode. So let us see, diode will provide useful power because of the heater. When the heater heats the cathode, there is a power that produced from that cathode surface. So by heating the cathode, we get electron as well as we get the energy. This energy strikes the anode surface to produce cathode rays. Cathode rays produced after electron is emitted from the cathode surface and heated to the anode and produce energy. And there is a ray. This ray is what we call cathode rays. Cathode ray is a beam of electrons moving through a vacuum at high speed. It is what? A beam of electron that moving through a vacuum at high speed. They are produced by an electron gun. Student, what I tell you is this: electron gun is contain anode 1, anode 2, as well as the cathode, and also heaters controlled by electron gun, which is a vacuum tube device. Student, this cathode ray also used for controlling the number of electrons. It controls what? The number of electrons in which emitted from the cathode surface. And this is cathode ray tubes. This is the diagram of cathode ray tubes. There is what? Cathode, heated cathode. This is heated cathode. This is what? Heater that is connected AC voltage. There is anode. Here is anode. This is what a tube is. A fluorescent screen is at this point. It is a vacuum. If you look, the anode at high potential than the cathode. This is the reason why I say electron is attracted toward the anode. This simple diagram of the cathode ray tubes. So, unlike the diode, the voltage on the anode may be as 5,000 volt relative to the cathode. The voltage of anode is higher than the voltage of the cathode. So let's see, after looking at the cathode ray, let us see X-ray tubes. X-ray machine is also a vacuum tube device. Electrons are released from the cathode by the thermonic emission and are then accelerated through the potential difference of the order of 1,000 kilovolts so as to hit the anode extremely with high speed. Student, when electron is emitted from the cathode surface, it produces high energy when it strikes the anode surface. These energies produce what? X-ray. X-ray. Therefore, the other ending being equipped with cooling, having fans or having cold liquid pumping around it. This is what? Anode. It is covering by what? It is being equipped with cooling or having fans or having cool liquid pumping around it. There is what? A cathode. Let us see how X-ray is produced. There is a heater. There is anode. When cathode is heated, electron is started to emit from the cathode surface. This emitted electron is strike with high energy on anode. After anode is struck by electrons that emitted from the cathode surface, it produces what? X-ray X-ray or X-ray window. This is the strike electron, the electron start from this cathode surface and strike this anode with high energy. This is how to X-ray is formed, how X-ray is formed. Let's see cathode ray oscilloscope. Student, let us see each part of this cathode ray tubes. Please pay attention carefully. It is very important to know this cathode ray oscilloscope. So this cathode ray oscilloscope have electron gun. Electron gun is contained. The first one is the heater. The second one is cathode. And the third one is there is anode 1 and anode 2. That is not mentioned in this graph. Therefore, when electron is emitted from the cathode, it passes in a straight line between Y plates and X plates. Student, you should have to read about X plate and the Y plate, because X plate and the Y plates are important to guide electron on the fluorescent screen. If there is no Y plate in the X plate, electron or spotlight does not reach on the fluorescent screen. So when a cathode is heated, electrons start to emit to the anode. It pulls to the anode. Anode is guided to the Y plates. The Y plate deflect electron horizontally, not vertically. Don't take as a mathematics. Y is along vertical. But in this case, while electron is emitted from the cathode surface and attracted by the anode, anode is guide this electron to the Y plate. The Y plate is guide electron along horizontal. But the X plate is guide electron vertical. Finally, the beam of electron is, or the spot is formed on the fluorescent screen. Student, on television, what we have seen a picture by this mechanism. And another way useful of vacuum tube device is a cathode ray oscilloscope. In cathode ray oscilloscope, the beam of electron produced is spot on fluorescent screen, what I've said now. So let us see about cathode rays, the property of cathode rays. Let us mention some points about the property of cathode rays. Cathode rays travel in a straight line. Cathode rays start normally from the surface of the cathode. Extremely mechanical process on the surface at which it fell. Produce fluorescence on certain substance on which they fell. And finally, you should have to read the property of this cathode ray. Student, I think you have more idea about this cathode ray. Let us jump to the other topics. Some use of cathode ray. Let us see some use of cathode ray. Cathode ray are some important. Among these, used as a direct current. We use cathode rays as a direct current because cathode ray can be used as a voltmeter, and we represent the voltage of the source of direct current as stationary spot of light on the screen. When the spot of light passing through cathode rays lays on fluorescent screen, we get a light. Therefore, cathode ray used as direct current. And also, it uses as sensitivity. This is other function of cathode rays. The sensitivity is the size deflection caused by the voltage applied across the Y of cathode ray oscilloscope can be adjusted using the gain control. So, for example, let us see how cathode ray used as sensitivity. If the sensitivity is set to 3 volts per centimeter and the spot is deflected by 2 centimeters. Student, if the sensitivity is set 3 volts per centimeter, the spot is deflected by 2 centimeters. Then, by unknown potential difference, we don't know about the potential difference that set the spot is by 2 centimeters. Our aim is to calculate the value of that potential that set the spot is by 2 centimeters or displace the spot by 2 centimeters. So the unknown potential difference can be calculated as follow. Look the diagram. The student, here is the first spot. At this first spot, the potential difference set is 3 volt per centimeter. There is a single, each triangle contains 1 centimeter. And the voltage read at this spot is 3 volt per centimeter. Look, an unknown potential deflecting the spot is 2 centimeters. So, student, if 3 volts deflected 1 centimeter, the spot is 1 centimeter, then 2 centimeters deflected, by how much voltage? We don't know the value of the voltage. Therefore, by Crick-Cross multiplication, x times 1 centimeter is equal to 3 volt times 2 centimeter. Then divide both sides by 1 centimeter. Then 1 centimeter. Here centimeter is cancelled by centimeters. 1 centimeter cancelled by 1 centimeters. Student, we get the final voltage that displays the spot 2 centimeters. 3 times 2 is 6 volts. This is an unknown potential that deflects the spot 2 centimeters. Student, you should have to do the problem that is given on June exercise book. Do the other problem. I do one for you. You should have to do the other problems. Let us jump to the next. So this is how to find the value of the unknown potential that deflected 2 centimeters. Student, x is equal to 6 volts. X is equal to 6 volts. So you should have to do example 2 by yourself. Let us jump to the next. So this is how to the second example. You should have to refer from your exercise book. I jump this over. Next, let's see cathode ray oscilloscope used as a time base. Another important use of cathode ray oscilloscope is used as a time base. So time base applies along X plates. If the time base is applied to signals made by a direct current, the trace changes from dot to line. Look this one. If the time base is, here is the time base is off. There is a dot. After time base is on, the dot is moved from left to right, like horizontal. It forms horizontal. This is another use of cathode ray tubes. So also, cathode ray is used as alternative current. And the voltage of alternative current varies between positive maximum to negative minimum. Here, if you take this positive maximum and this is negative minimum, when the time base is off, it is vertical line. After the time base is on, it is look like sine waves. Student, do you understand the use of cathode ray oscilloscope? Excellent. Now let us jump to the next. Finding the period, frequency of alternating current or voltage using cathode ray oscilloscope. Student, we learn how to find the unknown potential by knowing the deflecting the spots. Like that, we can find the frequency of the spot by knowing the deflection of the spot. Therefore, to know a signal is applied to the cathode ray oscilloscope and the time base is adjusted so that one complete wave appears on the screen. Let us see the diagram. Here is the diagram. When the frequency of Z is known, the frequency of Z is how 50 hertz. And we don't know about the frequency of this one. So we are going to calculate the value of the frequency of the second figure. Now, a figure shows the complete wave, it follows that the unknown frequency is twice that of the known signals it is. The unknown frequency is twice of the known frequency, means the unknown frequency is 2 times of the known frequency. This means that the known frequency is 50 hertz is given. So the unknown frequency is 2 times of the known frequency. The known frequency is 2 times of unknown frequency, means the unknown frequency is 2 times of 50 hertz. Because 50 hertz is what? The known frequency. From this diagram, you can look this. You can see this. The known frequency is 50 hertz. We don't know about the value of the unknown frequency for the second diagram. So we know that we have an information about the known frequency is 50 hertz, but the unknown frequency has 2 times of the known frequency. Therefore, 2 times of 50 hertz is about how much? 100 hertz. This is how to calculate the unknown frequency using cathode ray oscilloscope. Okay, student, let us see TV picture tubes. The TV in which you are seeing in your home is the function of this cathode ray oscilloscope. So the older sort of television, which is a big, heavy tube, is similar to cathode ray oscilloscope. Student, do you see about the old television? That is very big than the modern one. Therefore, this is a function done by the function of oscilloscope, cathode ray oscilloscope. This is the TV in which you have seen in last age. But the modern one is not like this one. This is done by cathode ray oscilloscope. This is done by cathode ray oscilloscope. A student, let us see conductor, semiconductor, and insulator. It is not new for you about conductor, insulator, and the semiconductors because you learn in different subjects. Conductor is a material which conducts electricity, while insulator is a material which do not permit the pass of electricity through them. While that semiconductor is the intermediate between conductor and semiconductor. Student, I think you know about more detail about insulator, which one is insulator and which one is not. And also you know about conductor, which one is conductor and which is not. And also you know about semiconductors, like silicon. It is a semiconductor because it's the intermediate between conductor and the semiconductors. It has 4 valence electrons in outermost shells. So this is what insulators and what conductors and what is semiconductors. This is a revision for you because you learned this one in last class. I revised this point. So let us see intrinsic semiconductor. Student, what does it mean when we say intrinsic semiconductors? What does it mean when we say intrinsic semiconductor? So this intrinsic semiconductor means pure semiconductor without adding an impurity. If we add impurity to this semiconductor, it becomes extrinsic semiconductors. So semiconductor become good conductor of electricity by 2 ways. One, by adding impurity. The second one is by raising its temperatures. By using these 2 mechanisms, semiconductor become good conductor of electricity. Without these 2 mechanisms, semiconductor is intermediate between insulator and the conductors. The electron is tightly bonded to the parent atoms. After applying high temperature, this electron is detached and moving to the neighboring atoms. While that, there is a hole is formed. There is a hole is formed means there is a flow of electron. There is a flow of electron means there is a current. Students, do you understand about this? Excellent. This is how Pure semiconductors are usually intrinsic semiconductors. For example, silicon, germanium is ETC are what? Semiconductors. Let us see another topic. Let us see lattice structure of intrinsic semiconductors. The lattice structure of intrinsic semiconductor is, because if you take silicon, the outermost shell of silicon contains 4 valence electrons. So, since they are full, like helium atom, they cannot permit to pass electron. Therefore, to permit electron passing through them, we apply high temperature. For example, look this one. Here is where there is electron, there is a hole. Electron is moving from this semiconductor, and the present there is hole is formed. While electron is go from this, a hole is formed. Therefore, when electron leaves an atom in this way, the atom becomes positively charged. The effect of electron leaving atom is therefore create a positive charge in semiconductor. This positive charge is called a hole. A hole is formed when electron is detached from the parent atom. This is the diagram shows this electron is moving or leaving this lattice atom. While it leaving this lattice atom, there is a hole, positive charge is formed. Since there is a positive charge, there is a hole is formed, this semiconductor become nearer to conduct electricity. Look this one. When electric field is applied to this semiconductor, that means when it is connected to the source of EMF, the electron and the holes moving in opposite direction. When we connect to the applied EMF, the electron and the hole moving in opposite direction. Look this diagram. Here, electron is moving to this direction, and the hole is displaced in another way. So, why is this? The cause the hole of appear to move through the lattice. The hole is moving through the lattice. This motion happens in the opposite direction to the motion of electron. You know the motion of electron from negative to positive, but this is opposite. This is opposite. So the current in pure semiconductor consists of free electron moving through the semiconductor lattice in y direction with equilibrium positive charge, holes moving the other direction. Look this one. We say that electron and a hole is moving in opposite direction, we said. There is what electron, there is a positive hole. P-type semiconductor is formed. We see this later, how P-type semiconductor is formed. Now let us see the movement of electron only. So there is a hole. This hole is about to be filled by incoming electron. When electron is come, the hole is filled. And this is a hole migrated across due to electric field along the crystals. This is how this motion of electron in lattice is formed. In lattice is formed. Let's see charge carrier resistance in semiconductor. While the resistance of a metallic conductor rise as the temperature is rise. Student, why? Do you know the reason? I say that the resistance of a conductor is rise or increase as temperature is increased. This is because of electron have highly energy, have highly kinetic energy. They collide each other while they moving in the wire. At that reason, the temperature, as temperature is rise, resistance of the conductor is what? Rise. But for semiconductor, the resistance is decreased if we increase the temperature. Student, why? Because of while we increase the temperature of semiconductor, electrons start to emit from this metal surface or from this lattice semiconductors. At that time, this semiconductor become good conductor of electricity. That is why I say that semiconductor become good conductor by applying two mechanisms. The first one is applying high temperature. The next one is by adding impurity to these semiconductors. A student, Let us say some points about how p-type semiconductor is formed. P-type semiconductor is formed when an atom of have 3 valence electron in outermost shell is attached or combined with a semiconductor, for example, a silicon. Since, for example, take a boron, it has 3 valence electron in outermost shell. But silicon has 4 valence electron in outermost shells. When they come to form a bond, there is 1 electron is leave or a scarcity of 1 electron. We lack 1 electron to fulfill the bond. This 1 electron form a hole. When such type of impurities added to semiconductor, p-type semiconductor is formed. N-type semiconductor is formed. For example, if the phosphorus atom combined or added to semiconductor silicon, after forming the bond, 1 electron is left. After forming the bond, this 1 electron is left and moving to the neighboring atoms. Then taking electron means it should be what? N-type semiconductor is formed. Therefore, N-type and the p-type semiconductor formed by the adding impurity of an atom to the semiconductors. Student, I think you understand about p-type and N-type of semiconductors. The majority charge carrier for N-type semiconductor is electrons, and the minority charge carrier for a hole is, for a positive charge is a hole. Students, this is what I have for today. Next, we are going to see about semiconductor or impurity doping. Until then, please read your exercise book and do the problem on your exercise book. Until the next lesson, goodbye, my students.